And that way you guys will have a study guide. Remember, the study guide is incredibly similar to the actual quiz, just like your other one. All study guides are incredibly similar. So I need all earbuds out so I know you're listening. Everybody's paying close attention. Yeah? All right, so for this first one, this is our negative exponent. So what do we do to fix it when it's a negative exponent? Landon? Yep. 1 over 3 to the second power. Right? So we want all of our answers in exponential form. So that means that we're going to have exponents in our answers, and they need to be positive exponents. So that's why we had to fix this one by flipping it. Right? How about number 2? This is a quotient situation. So what do we do with our exponents when we have quotients here? What am I going to do with this -3 and this -5? Maggie?
You would subtract them, but technically you would add them because there's going to be 2 subtraction signs together.
Correct. Minus a negative, so we add. So -3 plus 5 is 2, so my answer is just going to be 4 squared. Right? And we practiced that, and in your notes I had you write, be careful. Remember? Twice? Yeah. Okay. Number 3, everybody should have gotten this right. This is the 0 exponent rule. Anything to the 0 power equals 1. Oh, you guys. What?
My notes says 0.
No, they don't.
I swear they do.
Then you might have written it down wrong. Everything to the 0 power will always equal 1. Yep. Yep. Okay. And then for this one, this was one of the first things we did. We're multiplying here, so what's the shortcut when you're multiplying and they have the same base? Add. So I have 2 to the -7 plus 6, which is going to give me 2 to the -1. But I can't leave it like that because it's a negative exponent. So what do? We write it as a fraction. And you could have it 2 to the first power, or you could just have a 2. Those are the same value. Right? So this was, we subtracted, right? Write yourself a note.
You always subtract when it's division.
Yep. This one we added. This is the 0 rule. And this is the negative exponent rule. Right? So you have notes on all of those. Where else do you have information about those?
Green.
And your law of exponents color wheel? The little flippity flops? Yeah? Rylan, I know you have it back there. Yep. Okay, questions about problems 1 through 4. Let's look at 5 through 8. So this is where we have to figure out what could x and y be so that when they add, they make 8. And pay close attention here. X cannot equal y. If x was the same as y, then you would only need an x or you would only need a y. You wouldn't need 2 separate variables. So come up with 2 numbers that when you add them, you get 8 where they are not the same value. Maggie, what do you have?
6 and 2.
Sure. What else could you have? What could another one be? Sophia?
5 and 3.
5 and 3. I heard someone else say that. Hannah?
I had
7 and 1. What about like 14 and -6? Is that going to give me a positive 8? Sure is, right? So in this section, you're not all going to have the same answer. That would be very bizarre. But as long as your 2 numbers here do in fact add up to 8 and they are not the same value, then you'll get full points. How about for number 6? What do I need to do with this x and this y? So this was adding.
Subtract them.
Yep. This is going to be a subtract one. Right? So what could I subtract to make 8? Harmon? 10 and 2. What else? Landon? 16 and 8. What else? Maggie?
18 and 10.
Sure. 4 and negative 4, right? Because minus and negative, I'd be adding them. See what I did there? You get a little crazy, get a little fancy. Okay, let's move on to number 7. Power to a power. What do these two numbers, what am I going to do with those?
Multiply.
Multiply. So what can I multiply to make 8? Kind of limited here. There's only so many things you can do. Carmen?
Well, I did like X, 0, and 5.
Well, the problem with that is that 0 times 8 is 0, and then the answer would just be 1. But what could you put instead of a 0? A 1. You could do 1 and 8. What else could you do?
4 and 2.
4 and 2. That's pretty much it. Those are really your only options there. Okay. And then the last one, what would I have to make x so I have to force it to a numerator? What does this have to be so that I would have to force it to a numerator? What do you think? Landon? Negative 8. Right? That would force it, so it's 5 to the 8th over 1, which is the same as 5 to the 8th. Yeah? Okay, next page. Let's turn this over. So this section is a little bit, it looks more confusing than it really is. Okay? So what we're doing here is we're going to simplify this, meaning we're going to go through all of our rules and we're going to get it down to one base and one exponent, or maybe just a value. We're going to pay really close attention to the steps that we take. If one of our steps looks like one of these values, then that makes it equivalent and we circle it as being equivalent. Right? So let's work through this. Let's rewrite the problem. 3 to the negative 5 times 3 to the 4th squared. What would you do first here? What would be your very first step to attack this problem? What would you do? Carmen?
Distribute.
I'm going to do 4 times 2, right? I'm going to distribute this 2 in here. So I'm going to end up with 3 to the negative 5 times 3 to the 8th. What would I do with that negative 5 and that 8 now? What's my multiplication rule? What's the shortcut? Add, thank you. I'm going to add those. So what is negative 5 plus 8?
Positive 3.
Positive 3. And then if I were to actually do 3 times 3 times 3, what would I get? 27. So what you're going to do now is look at all these steps we took. Do any of them match these expressions over here?
No.
Which ones? Yep, we have B and we have D. That's it. So you work through the process, show your whole process, and then you find the ones that match on the left. Those are considered the equivalent expressions. All right, let's do the next one. What would I do first? I have 2 to the 3rd over 2 to the 5th, all raised to the 2nd power. What should I do first? Carmen?
Distribute.
Yep, I'm going to do 2 times 3 and 2 times 5. So I'm going to get 2 to the 6th over 2 to the 10th. Now I have a division problem. What do I do with my exponents when I have a division problem?
Subtract.
I'm going to subtract. So what's 6 minus 10?
Negative 4. 4.
Right? I'm going to do 2 to the 6 minus 10. So then I'm going to get 2 to the negative 4th. Can't keep that negative. What do I have to do when I have a negative? What's the rule? Yep, I'm going to put them, right? I have to move it to the denominator. And then what is 2 times 2 times 2 times 2? 16. Do any of these steps look like any of these answers?
All of them.
All of them. Isn't that convenient? This shows up, this shows up, this shows up, this shows up. Now, the way this is going to be graded tomorrow, each of these is worth half a point. But also up here, not circling this is also worth half a point. So circling or not circling accurately is worth half a point. So number 9 is worth how many total points? 2. Number 10 is worth how many total points? 2. Good job. So some of you may have been looking at this and going, I have no idea what's going on, but hopefully you feel a little better now that you've seen how to work it out. You know the math, it's just a different way of looking at the math. Sure, Mrs. Marsh. Okay, last 2 questions. Somebody tell me, how did you work out number 11? What did you do? Landon. Mm-hmm. Mm-hmm. Perfect. And we want our answers in exponential form. Don't you try to figure out 3 times itself 10 times. So this would be your final answer. Did anybody flip this down to the denominator to begin with and then add the 2 and the 8? You still get the same answer? I always flip last, but some people like to move it around early. You'd still get to 1 over 3 to the 10th. Hannah, how are you doing on this? Good? Okay. All right, so then our last question, number 12. I have this 4 out here. What do I need to do with it? Jillian, what should I do with that 4? Yep, I'm going to distribute to both of these values. So I'm going to get 1 to the 4th over 6 to the negative 28th. What's 1 times 1 times 1 times 1? 1. So my next step is just going to be 1 over 6 to the negative 28th. But I can't have that in my denominator, so what am I going to do with it? Yeah, I'm going to put it over 1. So my final answer would just be 6 to the 28th power. Questions, comments, concerns? Everybody have a completed, accurate study guide? You fixed your work as you went along? Yeah?